Hey everyone, welcome to Mills Renos, where we dive into the latest in bathroom remodeling, handyman tips, and everything you need to know to upgrade your home. I'm Mel, and today we're talking about the critical mission you sent us on. Installing a prefabricated shower base the right way. We want to guarantee a professional, leak-free result, for the long haul.
Yeah, it's a great stack of sources you sent over. Contractor guides, manufacturer specs, even warranty info. Good stuff. Our goal today is really to give you that shortcut to getting it right, structurally perfect. We're going to dissect the three biggest risk zones that kept popping up in all this material.
That's right. It's all about prevention today. We're unpacking everything. How to stop that subfloor deflection, why that mortar bed is basically mandatory insurance, the crucial difference between sheet and liquid waterproofing, that's a big one, and why skipping that final quality check, the flood test, is like the original sin of shower installs.
Seriously? Let's start right at the bottom.
Yeah.
Because the sources make it crystal clear, right? If the structure underneath fails, that waterproof base isn't going to do you much good. It's useless, basically.
Okay, let's unpack this then. Before we even touch the shower pan itself, the sources are hammering home this point about the subfloor. It's the foundation of preventing failure. So for a new build or a reno, what's the number one thing? The absolute critical requirement. And why does getting this wrong lead to so many, long-term headaches?
Okay, number one, the subfloor must be perfectly level. And just as important, structurally sound. No bounce. We need to prevent deflection. That's that slight movement or bounce you sometimes feel. An unlevel floor, that means poor drainage, water pools, and deflection. That means the pan itself flexes, maybe unevenly. That flexing over time is what leads directly to those little hairline cracks, often right around the drain first.
Yeah.
And eventually, total system failure. Years down the line, maybe, but it happens.
Yeah, I was actually surprised how specific the sources got about the materials. To guarantee that structural integrity, what are the specific prep steps a contractor really needs to take? What's the prescription?
Right, it's like structural insurance. The
Yeah.
standard call is for 2,332-inch or 34-inch plywood subfloor panels. Good, thick stuff. And they recommend applying a really generous half-inch bead of construction adhesive right on the joists. It's not just for bond strength, though that's key. It also helps prevent those annoying squeaks later. Then the screwing pattern, they say it's non-negotiable. 2-inch construction screws every 4 to 6 inches along the perimeter, that's tight, and then 12 inches apart in the field, the main area, that tight pattern around the edge. That's really key to stopping edge deflection.
Okay, but what if you pull up the old floor and find the joists themselves aren't level? Happens all the time in older homes. We can't just rely on shims and hope for the best, right?
No, not if you want that job to last and stand behind your work. If the joists aren't level, you absolutely have to sister new joists on. That just means attaching new straight lumber like 2x6s or 2x8s right alongside the existing ones. You clamp them tight, then secure them really well with 3-inch construction screws. Every 8 inches, staggered pattern. This basically creates a brand new, perfectly level plane to support your plywood subfloor. And then, last couple checks. Make sure the floor and the wall studs are at a perfect right angle. That 90 degrees is critical. And you need that pre-cut hole for the drain pipe. Usually about 5-inch by 5-inch works.
Okay, so floor solid, rock solid. Now we move to the first actual piece of hardware, the drain assembly. You mentioned high-risk zones. This is number 2, right? Often installed too tight or sealed wrong.
Exactly. Probably the weakest point of any prefab base is that drain connection. It has to be perfect. So you install the drain flange into the base first. You use plumber's putty or silicone, but only on the underside, the surface that actually contacts the base. That forms the first water barrier. Then, from underneath, you put on the rubber gasket, then the fiber gasket.
Okay, and that nut underneath. If I crank down on that too hard, what am I actually risking? Is it the pan cracking or wrecking the seals?
It could be both, but primarily you risk damaging the base material itself. Fiberglass, ABS, whatever it is. The sources are really specific. Do not over-tighten. Use a wrench. Yeah, get it snug. Snug means the gasket is compressed enough to make a good seal, but stop there. Cranking it down too hard can actually warp the pan material around the drain. It stresses it. Then even minor movements later, or just temperature changes, can cause a crack right there. Or it messes up the gasket seal prematurely. So, snug. Definitely not strained.
Okay, got it. Yeah. Now, here's where things get really interesting, I thought, because the sources were almost unanimous on this next point. The mortar bed. Lots of manufacturers will say, hey, if the subfloor is level, you don't need mortar. But pretty much all the pro sources, the contractor guides, they insist on it. Why? Why is this such critical structural insurance?
Yeah, that's a great question. The mortar bed is basically the pan's structural lifeline. It deals with point load stress. Think about it. When you stand in the shower, your weight isn't spread out evenly, right? It's focused right under your feet. Without solid, continuous support underneath, that focused pressure, that point load, makes the base flex. Just slightly, maybe, but it flexes. A good stiff mortar bed, maybe an inch to an inch and a half deep, it distributes that stress across the entire subfloor area underneath.
Right. I know some installers try to cut corners here, maybe use a few blobs of construction foam or stack up some shims for support. Why did the sources seem to think that was so risky compared to doing a full mortar bed?
Because foam blobs or shims, they only give you support in specific spots, localized support. They actually create high stress points right where they touch the pan, and that leaves big sections of the base completely unsupported, totally vulnerable to flexing right between those spots. The mortar, usually a sand mix, sand and cement, or sometimes you can use a thick bed thin set. It fills every single void. You get total continuous contact and support. That's the key difference.
Okay. So we do the dry fit first, obviously.
Right.
Mark our alignment lines, then mix up that stiff mortar,
Right.
spread it out, we drop the pan in. How long do we absolutely have to wait before we can even step on that base?
Minimum 24 hours. You must let that mortar harden completely before putting any significant weight on it. You press the pan down firmly into the mortar mix, get it perfectly level, check all directions with your level, clean up any mortar that's squeezed out around the edges, and then walk away. Seriously, don't rush this cure time. If you step on it too soon, you compromise the very structural integrity you just worked so hard to build.
Right. So structural support is done. Mortar's cured. Now we hit the third major failure point you mentioned, the transitions. The base itself, yeah, it's waterproof. But the seams, where the pan meets the wall and where it meets the curb, that's where water loves to find a way into the structure. So what are our options for really locking down this transition?
Well, this brings up a really important question you have to answer first. Are you using a sheet membrane system or are you going with a liquid applied system? They both work, absolutely, but the methods are totally different, and getting the application right, the consistency, is critical for both.
Okay, let's start with the sheets. Like the Schluter-Curdy system is really popular. The sources seem to call these the most robust, maybe easiest for getting uniformity.
Yeah, sheet membranes have that advantage. They're factory engineered, right? So you get guaranteed thickness, guaranteed consistency. You're not guessing. They're typically applied using thin set mortar, but, and this is really vital for you listening, you often have to use unmodified thin set for these membranes, and you need to apply it with a specific trowel, usually a small V-notch or like a 18-inch by 18-inch square notch trowel specified by the membrane maker.
So hold on, why that distinction? Modified versus unmodified thin set. Why is that so critical when you're putting down a waterproof membrane?
It really comes down to chemistry, how they cure. Modified thin set, the common stuff, has polymers in it, latex usually. Those polymers need air exposure to cure properly, to dry out. But when you press a totally waterproof, non-breathable sheet membrane like Curdy right onto that wet modified thin set, you basically trap the moisture. The polymers can't cure correctly because they don't get the air they need. It hinders the bond, can even stay gummy underneath. Unmodified thin set, on the other hand, cures mainly through hydration, a chemical reaction with water. It doesn't rely on air drying as much, so it can bond effectively to the membrane material even when sandwiched between the board and the sheet.
Oh, okay, that probably explains a lot of hidden installation failures right there. Using the wrong thin set.
Yeah.
Now, for that supercritical seam, the pan-to-wall joint, what's the specific application detail we need for the membrane band?
Right, you use the special banding tape, like Curdy band. It's usually 5 to 7 inches wide, and the application detail here is absolutely crucial. The band must extend at least 2 inches beyond the shower pan flange up onto the wall backer board, and it also has to overlap onto the pan flange itself by at least 2 inches. You need that minimum 2-inch overlap on both sides of the joint wall and pan to guarantee you have a continuous seal and a solid bond across that transition.
Makes sense. Okay, now for the folks who prefer rolling on their waterproofing, the liquid membranes, what are the absolute non-negotiables the sources laid out for those?
Liquid membranes, like RedGuard or Hydroban, they're elastomeric. That means they stretch a bit, which is good. The big challenge with liquids is achieving the correct, consistent thickness. That's everything. You usually need 2, sometimes 3 coats, applied carefully with a roller or brush. You're aiming for a specific dried thickness, typically somewhere between 30 to 50 mils, depending on the product. Check the specs. You absolutely have to follow the manufacturer's directions for application, dry time between coats, and ideally, use a wet film gauge to check your thickness as you go. And one more thing. Sources say anti-fracture fabric or reinforcing tape is necessary in all the corners and joints when using liquids. That fabric helps prevent the coating from cracking if there's any slight movement in the structure later on.
Okay, so membrane is chosen, either sheet or liquid. But before any cement board or wall panels actually go up, there was this extra step mentioned, like behind the scenes, involving butyl tape flashing behind where the backer board will sit. Sounds like a belt-in suspenders approach, the last line of defense.
It absolutely is. It's a crucial flashing step, and the pros insist on it for ultimate long-term protection. It's mandatory in some specs. Before you install your cement board or other backer, you use a 4-inch wide butyl flashing tape, sticky stuff. You flash the vertical lip, the flange of the shower pan directly to the wood blocking between the wall studs. The sources stress this tape is that last line of defense. It catches any water that might inevitably get past the tile and grout over the years. It channels that water back down into the pan, stopping it from getting into the wall cavity where it causes rot and mold.
And what about the corners? Those always seem like the weakest points.
Yeah, corners need special attention. You use separate, maybe 6-inch pieces of that same butyl tape. You carefully fold and press them tightly right into the corner intersections, maybe using a putty knife to get a good crease. Corners see the most stress from movement and are prime spots for water ingress. So that extra reinforcement before the main backer board goes up is essential.
Okay, tape is on. Now we move up the wall. Installing our cement board or maybe a waterproof panel like Weedy or Curdy board, we need to protect that final feel right at the bottom edge. What's the specific installation detail there? How does the board meet the pan?
Right, the backer board absolutely must overlap the flanged edge of the shower base. It comes down over top of that flange. But, and this is critical, you must leave a small gap, typically about 1/18 of an inch, between the bottom edge of that wall panel and the horizontal surface of the shower base or curb. Don't run the board tight down. That gap is vital. It gets filled later with flexible sealant.
Okay, why the gap? Why not just butt the cement board right down tight against the pan for a cleaner look initially?
Because that gap and the flexible silicone caulk that fills it later is the only thing that allows the wall structure and the fixed shower pan to move independently. Houses move. Temperature changes cause expansion and contraction. Things settle. If you butt that rigid cement board directly against the pan, any tiny movement transfers stress right to that joint. That stress will eventually crack the grout or the caulk if you put it over a tight joint, or worse, it could even crack the rigid backer board itself. And a crack there, that's catastrophic for your waterproof seal. That 18-inch gap filled with flexible silicone is non-negotiable for longevity. And while we're talking transitions, let's connect this to the bigger picture, the shower curb. That needs special attention too, right? It's where the whole shower system kind of ends and the main bathroom floor begins.
Yeah, especially if it's a custom curb, maybe built from 2x4s. How do we make sure that curb is totally sealed before any tile goes on?
You have to wrap it completely. Treat it just like a mini wall. For those custom wood curbs, you wrap them fully with your chosen waterproofing membrane. Usually that 7-inch wide Curdy band or an equivalent sheet membrane works well. And crucially, you need to use a specialty sealant like Curdy Fix is often specified right at the inside corner where the vertical curb meets the horizontal pan surface. You put a bead of that sealant before you embed the waterproofing band and thin set. It ensures a really solid, flexible bond at that critical inside corner.
And what about protecting the bathroom floor on the outside of the curb from splashes when the door opens?
Yeah, protecting that outside edge is key for the warranty, for long life. You use those specialized preformed outside corner pieces, like Curdy Carrot corners. You use them to wrap the membrane down the outside face of the curb and turn it onto the main bathroom floor for a few inches. This stops any water that splashes out or runs down when the door opens from getting under the bathroom floor tile right there. It ensures that water stays on top of the tiled surface, which ideally should also have some waterproofing in that immediate splash zone outside the shower.
Okay, wow. We've done all the prep. Subfloor solid level, mortar bed cured solid. Walls are up. Transitions meticulously waterproofed, overlapped, sealed. Feeling pretty good. Is the next step finally tiling? Please say yes.
Absolutely not. Not yet. Before a single tile goes up, you must perform a flood test. This verifies that your entire waterproofing system, the pan, the drain connection, the walls, the curb, the corners, is completely leak-free. Skipping this step. The sources universally called it the single most expensive common mistake. Because if there is a leak, finding and fixing it after the tile is up often means demo, tearing out finished work. Nightmare scenario.
Yeah, that 24-hour wait for the test feels brutal when you want to get tiling, but it's necessary, isn't it? There's literally nothing worse than marking that water line, Coming back the next day and seeing it's dropped, and then realizing you have to start hunting for the leak,
Yeah.
maybe tear out the ceiling below.
Yeah.
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 That test time is worth the peace of mind. Okay, give us the procedure again, the flood test critical checklist.
Okay. Step 1. Wait 24 hours after all your membranes, sealants, everything is installed and cured. Give it time. Step 2. Securely plug the drain. Use a proper 2-inch test plug. Those inflatable ones often work best. They give a really reliable, tight seal. Step 3. Carefully fill the pan with water. Fill it right up to just below the top of the shower curb or threshold. Don't overflow it.
Okay, plugged and filled. How long does it have to sit there? What's the required monitoring time?
The sources are pretty firm on this. Let the water sit for a minimum of 24 hours. Some recommend going as long as 72 hours, especially for complex builds, but 24 hours is the absolute bare minimum standard. During that time, you monitor the water level carefully, mark it with a pencil right when you fill it, and most importantly, you need to check below the shower floor. If you can, get access to the basement or crawl space or the ceiling of the room below. Look carefully around the drain penetration and in the corners for any signs of moisture, seepage, drips, anything.
And if the water level holds steady for that 24 or more hours, no drips below. We pass.
You pass. Congratulations, you have a verified waterproof system. You can drain the water, let it dry thoroughly, and then you're finally ready for tile.
Okay, but what if? What if it leaks? What's the immediate action plan?
If it leaks, if that water level drops noticeably or you find moisture below you, immediately pull the plug and drain all the water out. Then the detective work begins. You have to carefully inspect everything to find the source of the leak. Maybe it's a pinhole in a liquid membrane. Maybe a corner wasn't sealed perfectly. Maybe the drain connection wasn't quite right. You identify the problem, you make the repair properly, let the repair cure fully, and then you have to perform another full flood test. Same procedure, same duration. You absolutely cannot proceed with tiling until that shower system holds water perfectly for the full test duration. Period.
Okay, so what does this all boil down to? We started this pile of sources, and we've ended up with a pretty clear roadmap. It seems like the difference between a shower that lasts a lifetime and one that causes costly failures really comes down to just, like, three main things. A level, solid subfloor that prevents movement. Check. A fully supported pan, thanks to that non-optional mortar bed distributing the stress. Check. And then meticulous overlapping waterproofing at all those transition zones, walls, curb, corners, all verified by that mandatory flood test. Check.
Exactly. And if you look back at that common mistakes recap from the sources, the biggest pitfalls contractors run into are deceptively simple but devastating. Number 1, skipping the mortar bed, just using shims or foam, leading to flecks and cracks. Number 2, starting with an unlevel or bouncy subfloor, which ruins drainage and stresses the pan. Number 3, skipping the flood test because they're in a hurry or overconfident. Big mistake. And number 4, using the wrong type of thin set under membranes, which compromises the bond right from the start.
Right. Okay, so you pass the flood test, everything's bone dry, you're ready to tile. But wait, there's that 18-inch gap we left. The one between the bottom of the tile or backup board and the shower base itself. That needs one last crucial step, right, to maintain that flexible joint.
It absolutely does. That gap is critical, and filling it correctly is the final seal. After tiling and grouting is done and cured, that 18-inch gap must be filled completely and neatly with a high-quality 100% silicone caulk, preferably one with mold inhibitors. That bead of flexible silicone maintains the waterproof seal at that crucial junction, but it also provides that necessary flexibility, allowing for that tiny bit of differential movement between the wall structure and the fixed pan. It prevents stress buildup and cracking right there at the most critical joint in the entire shower assembly. Don't skip this final caulk line.
That really is the perfect wrap-up of what can feel like a complicated process. Thanks for breaking it down. Before we sign off, here's kind of a provocative thought that came up when the sources discussed drain tech. They spent a lot of time cautioning against blocking or not protecting the little weep holes on traditional two-part clamping ring drains, letting water escape the mortar bed. But if some of these newer drain technologies, like the integrated bonding flange drains or linear drains, are basically eliminating the need for those weep holes entirely, does embracing that kind of system change represent maybe the biggest leap forward in leak prevention for the modern builder? Compared to just trying to get the traditional, more complex methods perfect every time? Just something for you to chew on as you maybe plan your next shower installation.
That's a really interesting point, that potential for engineered simplicity, reducing the number of potential failure points like weep holes. That certainly seems to be the direction the industry is pushing towards. Excellent insight to end on.
Absolutely. Well, thanks again for supplying all those sources for this deep dive. It was great digging into them. We'll catch you on the next one.